right, so I'm going to be using my calculator to calculate probabilities in the standard normal distribution. And then we might just do the normal distribution as well. So how do I know these are all standard normal distributions? Because they've used the letter Z. So if you use the letter Z, you're talking about a standard normal distribution. And what does that mean? It means that the mean is equal to 0, and it means that the standard deviation is equal to 1. And that's the case for all of these because their Z is our variable. Okay, calculator. This is going to be really straightforward. We're going to go into our stat mode of our calculator. And then we're going to go down to distribution, DIST. And there's all sorts of distributions, but we're using the normal distribution, F1. And then you've got these three options here. We're using the normal cumulative distribution, NCD. Okay, now it says, find the probability that Z is less than or equal to 0.74. Okay, so less than 0.74. So I'm just going to draw my normal distribution first, just so you can see what it looks like. Don't have to do this. I'm just showing you so you get a feel for what's happening. Now, the mean is 0. The standard deviation is 1. We want to find the probability that Z is less than or equal to 0.74. Now, 0.74 is about there, let's say. We want to find this area here, the probability that it's less than that. Okay, now, so I'm going to enter a lower value, just a really low number. Say like negative a million, whatever, negative 100,000. An upper value, now that's the limit that I've got there, which is 0.74. Type that in. And then I just need to make sure those are right. Standard deviation of 1, mean of 0. And I can just click execute there. And I'll get a probability of 0.77. Now that makes sense. 50% of people would be below 0, so I'd expect a number larger than that. So 77% probably makes a lot of sense. Good rule of thumb, go to 4 decimal places, so 0.7704, I believe. 0.704. Yep. And then we can just do the same for all of these questions. It's going to be really, really fast. The probability that Z is greater than 0.16. So this time it's a curve that looks like that. 0.16 is here, and we want this. So I'd expect it to be just a little under 50% would be my, hopefully is my answer. All right, so lower bound, this time 0.16 is my lower bound. My upper bound is like big, and then I can execute that, and I'll get an answer, 0.4364. The next one is the probability of Z is greater than negative 2.71. Let's take a look at what that would look like first of all. Okay, so here's there's 0, negative 2.71, so that's like way down here somewhere, and we want the probability that Z is greater than that. So it's going to be all of that. So it's going to be pretty close to 1. It's going to be like 0.9 something. Let's see. Distribution, normal distribution, NCD. All right, so the lower value is negative 2.71. The upper value is a very large number, and I get 0.9966, and that's about what I expected for that. 0.9966. And then this last one, it's probably the easiest question in the whole page because we don't have to think about it at all. We can just go, the lower bound is, try again. The lower bound is negative 0.72. The upper bound is negative 0.41. And I get an answer of 10.51% or 0.1051. Okay, they were all standard normal distributions. I think I can probably stand to just talk about the normal distribution more generally now. So all of them were standard normal distributions, and by that I mean that they had a mean of 0 and a standard deviation of 1. However, distributions can have any mean and any standard deviation. This one, it says, if the random variable is from a normal distribution with mean, with a mean of 16 and a standard deviation of 4, then the probability that x is greater than 11.5 is equal to. Okay, so what that says is we've got a normal distribution with a mean of 16 and it's like a standard deviation of 4. And we want to know the probability that x is greater than 11.5. So 11.5 would be down here somewhere, and we want to know the probability that it's greater than 11.5, so to the right of that. So I'll just get out my calculator. And it's very straightforward here. The lower value is 11.5. The upper value is just a really, really, really big number. The standard deviation is 4. The mean is 16. And I get a probability of 0.8697. 0.8697. Okay, now with all of these questions, if you're in an exam situation, make sure you write down whatever it is that you typed into your screen. So the lower, the upper, the mean, and the standard deviation. And then we can do a nice little, like an easy little question here. The lifespan of dogs is normally distributed with a mean of 12 years and a standard deviation of 2 years. The probability that a dog lives for less than 9 years is. Okay, so again, it's a normal distribution. Lifespan is normally distributed with a mean of 12 years, so 12 there. Standard deviation of 2 years, so 2, like sort of like that. Less than 9. All right, so 9 is going to be down here somewhere. Oops. 9 is going to be down here somewhere, and less than 9, so we want this number down here. It's going to be like, I don't know, 20 something percent, 17%. Let's see. Calculator. So the lower value is like negative a million. The upper value is 9. The standard deviation is 2. The mean is 12. 0.0668. So the probability that the lifespan is less than 9 is equal to, let's see, what was my answer again? 0.0668. 0.0668. Okay, last thing I'll say about this, whether it says less than or whether it says less than or equal to makes no difference. There's a good reason for that. I'm not going to get into that here, but the treatment of it is exactly the same, whether it's less than or equal to. Talk to me in class if you want to know why that is.